So thank you everybody for showing up today. I know it's the last session of the day, probably some tired eyes, and hopefully I'm gonna keep you energized a little bit, talking about what VMware's doing with inside of the container ecosystem, inside the container space as well. Quick background on me and who I am. This is actually my fourth DockerCon, actually third DockerCon as a speaker. Was a Docker captain at one point. Came from a team where we were really focused on building a lot of persistence mechanisms and had one of the largest open source projects with inside of Docker that really built a lot of the persistence and storage with inside of there. So a lot of Docker volume driver stuff, but now I'm over at VMware, really focused on bringing a lot of the open source goodness into there, really focused on Kubernetes and really being involved with the Kubernetes community and making sure that we can bring a lot of the knowledge that's coming from there and pulling it into some of our product teams as well. So the topic for today's talk is really going to be focused around how do we operationalize Kubernetes to be able to give our developers a consistent and an environment that they're usually used to using, right? Because today's devs, this is typically what they want to be able to see, right? They're the vanguards for breaking edge or cutting edge technology. If we rewind the clocks back 4 years ago, like it was my first DockerCon, it was a different kind of crowd here, right? It was a lot of developers that were really pushing to figure out where this next wave of innovation is going to be going. And we kind of see this trend continually happen, right? I mean, the next thing that we're always wondering about is it going to be serverless next? What's going to be that next thing? I mean, let's face it, like every week there's a new JavaScript framework out there, right? And you've got to figure out how do we continually operationalize or how do we continue to use this stuff in a production kind of environment. So we look at developers really being those vanguards for breaking technology that are really trying to start pushing with inside of our enterprise deployments and our enterprise environments. Developers are also changing a little bit. They want to become a little bit more what's called like DevOps-y, right? They actually want to own the application. It's not to the days that we said we're going to take this application, we're going to toss over to the fence, and we're going to let operations worry about it. It's the fact that they actually want to run it. They want to run it from top to bottom. And the idea is that operations need to be able to give them the tool sets that they can be able to make that actually happen. And they have to continue using a familiar environment. I mean, if you're using Docker for Mac or Docker for Windows today, it comes with Kubernetes baked into it. Odds are they're probably using it to deploy their applications, figuring out how replica sets work, figuring out how they're utilizing persistent volumes. And they don't want to sit there and change that to actually start running in production. They want something that's completely familiar with them, especially if they're going to be owning the application at this point. And they are done with things breaking. The good thing about running it in Docker for Mac or Docker for Windows or Docker in the cloud or Kubernetes in the cloud or Kubernetes on-prem, you sort of have this base layer, right? You have this common denominator that is essentially the way that you know that you're going to have a consistent environment every single time it's going to be deployed. Now the ops side, on their hand, it's a little bit different, right? Ops don't want breaking. They don't want breaking changes. They want stability. They want something that they know it's going to be able to run, and they don't want to have to worry about it breaking because of a bad deployment or a bad piece of code. It wasn't regression tested properly. And so we look at this as a way that how do we give developers the environment they need to be successful? And if we want to be able to do that, well, we want to make sure that the installation itself is somewhat automated to a degree that we don't have to want to keep spinning up Kubernetes clusters. Or if the Kubernetes clusters are going to be somewhat automated, how are they aware of their infrastructure, right? Do they understand exactly what the underlying components are? How do they mimic it? How do they do their upgrades? How do they sit there and take care of any kind of scaling capabilities, right? So they have to be somewhat aware of their underlying infrastructure. At the same exact time, operations need some level of management. What are the management capabilities that go into it? And hopefully it's easy enough that it's just point click or whatever it is, or maybe it's just a few command lines, but it has to be easy for operations to be able to take control of this. Because if you're able to just hand over operations of a full Kubernetes cluster over and say, good luck, go run it, you're probably going to have a really hard time trying to get a lot of those operations folks on board to be able to say, yeah, sure, let's go ahead and learn a whole new infrastructure that you've just handed over to me, right? So we have to simplify it in a way that makes sense to them. At the same time, risk has to be assessed, right? The security teams are the ones that put the no in innovation, right? And we have to figure out how do we make sure that they're the ones that are comfortable with either running new types of applications, the images that are running with inside of your Kubernetes infrastructure or running with inside of the Docker containers themselves. And we have to also figure out how is it going to be simplified for day 2 operations. When the next version comes out, what's the process that you figured out if you're going to be utilizing some sort of configuration management through Ansible or something like that to sit there and do your updates, or are you going old school and SSHing into all your boxes and actually dropping new binaries or something like that. Figuring out a way that you can simplify this and hopefully automate it is really what people want to be able to do. So let's look a little bit at the lifecycle for the operations side of Kubernetes in itself. So you have this flat network. This is potentially a layer 2 or even moves to a layer 3 network, that router down there. And you have all the components for Kubernetes baked in here, right? So you've got your master, you got your workers. And they are all talking through certificate signing, utilizing these PEMs, talking that certificate authority, and now you have an encryption key on how they all talk to one another. The master nodes has all the components of what we're all familiar with seeing already. And these are the components that operations people need to understand. They have to understand what each one of these are doing. And not only that is, what is the individual upgrade process or maintenance release patch for each one of these that go on when the next version comes out. On the worker side, you've got your container runtime, you've got your kubelet, and these are really what you have to be focused on if you're going to be owning this part of the infrastructure where the containers are going to be running themselves. So we can utilize KubeSpray or KubeAtom and all these things to kind of get them up and running on day 1, right? But you've got other things to figure out. We got to worry about networking. How are the pods going to be routing out those external services that are going to be connecting back into the containers themselves? We got to worry about core DNS. If you're not aware, like in 1.11, core DNS is going to be the new Kube DNS that's going to be replaced with inside Kubernetes. So you've got to worry about DNS at that point. And regression testing. Just because we set it up a Kubernetes cluster once, that's fantastic. But how positive or how, I guess you'd say, confident are we that this Kubernetes cluster is actually functioning the way we intended it to, right? Between all the networking and storage and other security aspects that all go into it. So maybe we do have it up and running. Maybe it's great. And now we've got to figure out day 2. Well, we want to bring on more worker nodes. What's that entail? Have I figured out how to do it through configuration management yet? Am I just bash scripting the hell out of it to be able to automate it as much as I can? What about being able to upgrade? I want to be able to move from 1.9 to Kubernetes to 1.10. What's that upgrade path look like? Am I going to those boxes individually and doing upgrades and dropping binaries, or have I figured out a way to better automate it? Also troubleshooting, repairing. But now comes the even harder part. Now we figured out how to do it on our one cluster. Now devs are asking for multiple clusters, right? So what do we do when we need to do this multiple times over and over and over again? So trying to figure out how it's going to be repetitive. Well, we look at Kubernetes as really the best scheduler out there for containerized workloads, right? That's sort of what is being seen inside the industry. Now today we have the tools that are already there for developers to actually manage and own their applications, right? You've got kubectl and you've got your Kubernetes dashboard. That's really all they need to be able to run their applications and make sure that they're running successfully. Now, on the other hand, you need more than a scheduler because you've got the operations teams that need to worry about all the other components that go into it, from networking and storage. Maybe you need a new image repository, external services. How are these actually getting routed in and out of your Kubernetes cluster, right? So we got to figure out how that all works. Well, VMware has some more tool sets that actually help figure this out for you with different kind of plugins, right? So all this comes in a nice little package that is available to the platform team, what we call PKS, or the Pivotal Container Service, which is a complete enterprise-grade platform for Kubernetes, right? So I'll talk a little bit about these, and then we're going to dive into a demo as well. And thankfully, they've actually got fortune cookies underneath here, so we've got good luck today. So I'm going to take the opportunity and crack one open too. You better believe it. So let's talk a little bit about what each of these are really looking at when we dive into it. And really, when we look at the stack in itself, Kubernetes is one part of it, right? Docker is a part of it. It's a very critical part of it to make sure that we have that trusted container runtime. But you also have the scheduling and orchestration aspect of it, which is also very critical. But you've got a lot of different components there, from security and networking, where you've got to go and you've got to figure out, well, which is the one that works for you, your team, and your environment. Persistence, what's your storage story there? How are you going to be able to run it as well? VMware has an answer for all these, and I'll kind of talk about ones just really quickly as we move up the stack here. So, of course, on top of your physical infrastructure, we have vSphere. With that, we also have a project called Project Hatchway, which is an open source project from VMware that has, one, if you're looking just to run pure Docker, it's got your Docker volume drivers, but as well it has the in-tree volume driver for Kubernetes. And this allows you to utilize VMware's vSAN or any one of the other hundreds of other VMware certified storage partners that are compatible with vSphere. Right, that's actually a critical thing to understand is when you start looking at what storage aspect you utilize for persistence. You know, if you start looking at Kubernetes, there's about 12 today that are vendor specific inside of Kubernetes. That's all kind of being replaced now, utilizing CSI, using container storage interface. So if your vendor, your storage vendor, doesn't have any native capabilities into Kubernetes, you're kind of SOL at that point, right? So you have to look at them and start developing a CSI driver if you want to be able to utilize that particular storage vendor. So then we have other things that are up and down the stack here, right? And all these are actually a part of PKS. So I'll talk about each one of these just a little bit more in depth. So NSX is going to be your network virtualization layer. Bosch is going to be your lifecycle manager. That's also your automation component. That's actually going to be actually provisioning everything, as well as going to be checking the health of your Kubernetes cluster. And then also should mention that, you know, with PKS, this is a certified distribution of Kubernetes that has enterprise grade support. So you have support for Kubernetes as well as everything down to the Docker runtime itself. And we also have an open source project called Harbor that becomes part of this, and you get enterprise support. And I'll talk about that a little bit further in depth here in the next slides. And if you want to get into more of the monitoring, logging, and analytics, you can tack on the vRealize suite with Wavefront, and you can get a little bit more information into the actual applications that are running inside the containers inside the platform as well. So this is just a quick little architecture overview of how this does look. As you can see, the sort of layers that everything's built on top of. So you have vSphere, you have your storage components, you have your networking layer. Bosch is the one that's responsible for doing a lot of the automation for deploying these Kubernetes clusters on the fly. And you also have Harbor, which is your container registry. The PKS control plane not only just works as a way to quickly deploy these, as it's talking to Bosch, but it also functions as an API. So if you are trying to develop some sort of shopping cart for your application developers, where maybe they go today and they try to buy a VM from IT, well, now they want to buy a Kubernetes cluster. Go ahead, add that to cart, kick off your workflow, that then's going to kick it off, and now they have a Kubernetes cluster they can go and they can start developing against as well. So this is how easy it is. It's a one-liner, right? It's funny, at the booth today, we were sitting there thinking, what's a good demo to be able to show? And we're like, it's literally just one line. Like, there's really not a whole lot to show, right? So it's one line to be able to say, I want to create a new cluster. I specify an endpoint. This can be a DNS or an IP address. You have some prescriptive sizes. You got small, medium, and large. And you can say, how many nodes do I want? Do I want 3 nodes? Do I want 5 nodes? Do I want 50 nodes? And at this point, it's going to go ahead and start kicking off and start creating your Kubernetes cluster. Usually takes about 30 to 45 minutes for a 3 to 5 node cluster. All of a sudden, everything's up and working, and you're ready to start utilizing Kubernetes. So it's all building and creating these VMs from scratch, and you're off and running. Then we utilize Git credentials, and I'll show you exactly what that means and how you utilize this to sort of kind of create a good separation between ops and dev at this point. And I'll show that when I get to the demo. So quick little architecture, and I'm going to blow through this one real quick. So you have Bosch, which actually manages and deploys your virtual machines. It has its cloud provider interface, which is actually connected into vSphere. Kubernetes has its container networking interface, and that's connected into NSXT. Inside of PKS, you have the controller. You've also got your Cloud Foundry container runtime, which was called Kubo at one point, if you're familiar with that. And you also have Harbor, which is your image registry. Now, one of the things that it's actually doing here is we can talk to the API and we say, I want to create a cluster, right? And I'm going to say I'm going to create a few different clusters here. And as it goes, it's going to have all these different ones that you want to do, and you can have these based upon application types, lines of businesses, BUs, security boundaries, you name it, right? That depends on whatever works for your environment. The one thing about Bosch is it's continually monitoring all the components within inside all these clusters. So let's say, for instance, one of these worker nodes goes down. What happens? Well, Bosch is going to be able to recognize that, and if it can't turn the virtual machine back on, it's actually going to deploy another worker back into this cluster as well, so it re-gets to the state that it was in, right? So it's a configuration state management tool at the same exact time. We can also scale this. I can just say resize which pod or which Kubernetes cluster I want to do. How many more nodes do I want? I'm up and running, right? So this is another thing that you can actually utilize that API for. So if you figure out a way to, if you know your triggers and you know what kind of applications are getting sort of spikes and we want to add more workers into these particular clusters, that's another thing that API becomes very handy. On the NSX side, so this is the architecture of what it looks like for the networking controllers here. And you have essentially a router for every single namespace within inside of Kubernetes. And each one of these namespaces also has their own CIDR or their own IP address range. At this point, you also have the ability to do firewalls, you have load balancers, which I'll show a little bit more when we get into the demo in itself. And lastly, talking about Harbor, which is the image registry. It has role-based access control. You can do this on just a blanket username authentication, or it also hooks into LDAP. So once you have role-based access control, you can actually build, push your images. It has Docker's Notary built into it as well. So you can actually have signed trusted images. I know that it comes from Bob or Jonas or Sally or whoever it is, and I know exactly who's actually pushing these images up here, so they're trusted when I want to pull them down. It also uses Claire to scan images for critical vulnerabilities. It runs that every 24 hours to see exactly if there's anything new. And there's also the ability to say, I can set my risk tolerance, whether I want it low, medium, or high, depending upon the security vulnerabilities that are found. And if there is something that is immediately moving to a low or to a medium level, and it wants to run within inside of Kubernetes, it will actually stop. It's going to back off during that image pull process. Cool, so let me go ahead and just jump over to the demo real quick. Oh, this is a good time, right? So let's go ahead and open one of these up. I don't know if, we'll see if these actually have the funny sayings in here that they had on the keynote stage. If I had to guess, I'm gonna guess no, but we'll find out here. We're doing this just for fun. This is all ad hoc here, right? Oh, here we go. It is Zen-like. It says, what's in your Docker container? All right. I almost want to get the rest of them and see what else they say. But all right, let's go jump into this. So over here in this environment, when I get to it, let me go ahead and end the slideshow. So over here, I've got a VMware environment that I have kind of pre-provisioned for me. Now, what I'm going to do is look a little bit, I'm going to look at my PKS clusters. Which ones do I have already here for me? So I've created a small cluster here called DockerCon. And with inside here, I've got my raster, I've got 3 worker nodes, I've got my jump VM, I've got my Harbor image registry, and it's, like I said, everything was provisioned for me automatically. Now, as I'd mentioned, I can do other things. I can say PKS, I can say resize. If I wanted to, I can create it. Those are the commands that are available. Let me just show you real quick just so you can have a blanket idea of all the commands that are there. So I can actually create the cluster, I can delete the cluster. It's a complete one-line command, right? So super, super easy to be able to do that, as well as to resize it. If I want to get some more information about my cluster, PKS cluster DockerCon, I can see that, okay, so I've got 2 worker instances. I see the IP address of my master host, and we can see that the provisioning is completed, which good because I did it yesterday, so if it wasn't, we'd be in even deeper trouble, right? So let's go ahead and clear this out. Now the next thing we have to do is, what does our kube config look like? What do we give to our developers so they can actually access this PKS cluster, or they can actually access their Kubernetes cluster in itself? So we're going to say PKS get credentials, and we're going to say DockerCon. So it's going to fetch the clusters, and essentially what it's doing is it's writing my kube config for me. So I can do and I can see these are the tokens that I would actually give to my developers, right? So at this point, we sort of have this separation, right? And it's pretty valuable to see this right here, right? Where at this point, I can give this file to my developers. They can access the Kubernetes cluster utilizing these tokens, and they own the application from here on out, right? They can own everything from the deployments, the replica sets, persistent volumes, networking, everything from top and bottom, they own at this point. Whereas perhaps being on the operations side, all I care about is the infrastructure. I care about making sure that my Kubernetes nodes are at a specific revision that I want them to be at. They're compatible with the vSphere infrastructure lying underneath. And from here, this is really the kicking off point, right? So let's go ahead and let's create a new namespace. So I'm going to say kubectl. Well, let's look at our namespaces already. Oops. kubectl. Let's see. Yeah, I was about to say, I was like, it's NS, right? Oh, how about Git? How about that? Man, alive. So I've got my 4 namespaces that'll be here, right? So I've got my infrastructure and I've got the other ones that are default when you get within inside of Kubernetes in itself. So I'm going to say kubectl. I'm going to create a namespace and I'm going to call it dockercon 18. And when I do that, and of course you're going to see a namespace get created in here, but really a lot of the magic is happening behind the scenes. So let me come over to my NSX manager. I'm going to log in here real quick. Come on, fortune cookie, don't fail me now. There we go. So we're in here now. I'm going to go to the routing pieces right here. And once I pull this over, we're going to see that now here's our dockercon 18. We have our router in here. I can go to the switching. One of the unique things I'll see inside the switching is that when you're setting all this up, you essentially give PKS sets of network IPs and CIDRs that you want to dedicate to this particular these deployments, right? So as things are going out, you don't really have to think about it. So I know that this is a /24 that was given to this particular namespace, right? So cool. So we got that ready to go. And now we can see that within inside of here that when it creates that namespace, that you can create these networks, you create these switches that are all available to it. Now I'm going to come back through here and I'm going to do this one more time and I'm going to make sure that I'm setting my namespace correctly. So it's always going into the Docker 2018 here. So I'm going to say use context and I'm going to say dockercon 18. And I'm going to say the namespace, oops, I'm going to say use dockercon, and then the namespace is dockercon 18. Okay, so now I know that every single thing I'm going to provision is going to go into that particular namespace. Now, before I provision anything, I got to have something to provision, right? So I want to be able to say I want to move one of my images that I have built here locally on my laptop into my image registry. So I'm going to look at, say, Docker images, so I can just see what images I have available. And so I've got one I built right here that's going to go to the Docker 18, right? Now, before I do that, I actually need to go into Harbor and create a new project. See that one with Docker? Don't pay attention to that one. We're going to build a whole new one here. Let me go ahead and refresh this because I figured I have to log back in. So I'm going to go ahead and create a new project. In here, I'm going to call it dockercon 18. I'm going to set it as public. Now, when I come in here, this is where I get a little bit more ability to do some more configurations, right? So one of the good things about Harbor is actually has replication features built in. So I can actually have multiple Harbor instances up and running. They can be geolocated, and you can just replicate between each one of these as well. Now, inside the configuration, I can enable content trust, right? That enables me the ability to make sure that my images are signed. And I can also enable vulnerability scanning. So I can scan images on push to see if there's any issues with these particular images as well. And from here is where I can actually prevent vulnerable images if I wanted to set that, what is my risk tolerance, right? So I'm gonna go ahead and click save. Now, coming back over here, I'm gonna go ahead, I'm gonna say Docker push, and I want this particular image. And I'm gonna say V2. So it's gonna prepare, mounted, and it's now pushing. Oh, actually, you know what I did? I actually have I need to unset something real quick, because that would have been very bad. Let's see. Let's see if we do that. Okay, now let's try this again. Okay, so now that I go over here, if it works the way it was supposed to work, if I didn't screw it up, I'm actually gonna go in here and I should be able to see that my image is not signed, right? So at this point, it's not a signed image. Now, what happens when I try to be able to deploy this, when I said that I don't want any image that's pushed to my registry to actually be deployed to any of my hosts unless it's signed, right? So let's go ahead and let's look and see what that looks like. So within here, I have essentially this deployment, right? It also has a load balancer built into it, but this is the deployment right here. All it's saying is that I want to use that particular image, right? I'm going to go ahead and apply this. It's going to go ahead, it's going to create our service. Let's go ahead and look at our pods. So we need this one right here. Oh, do you see that last one over there? It said engine or pullback. So let me just look at it real quick, because that went a lot faster than it was probably going to. So it says error image pull. Let's go ahead and just describe it and see what we have here. Figure out why. So we pull it in here, and we can say that right here, it says this image is not signed in Notary, right? So we know from right at this point that we have a problem or it's working the way that we want it. We want to make sure that these images are signed, that we have some sort of trust, right? So before we go there, I also want to look in here. One thing I didn't mention is that vulnerability scan. So I can come inside here, I can look at the individual tag, and from here, it's actually scanning individual files and layers and packages within inside of here, and I can see what its risk level is. If it's fixed in a particular version, it's going to say it over here as well. So that's a way for me to understand what is the security vulnerabilities within inside of here when I am actually pushing and publishing my images. Now, through the magic of copying and pasting commands, I'm going to make this easy on myself. And I'm going to say Docker content trust equals 1. All right, so now if I push this image again, and actually I'm going to go ahead and delete this deployment. So it's going to kill the service, we're going to kill the deployment, and I'm going to push it one more time. Well, let's hope this works, because it didn't ask me for my hash that it wanted. Let's see. Tell you what, I'm going to make this go real quick, and I'm going to make this work. So we're going to create a new one real quick. Say Docker con. Just make it 19, right? Because everybody's going to be back here next year, right? So I'm going to go to configuration real quick, enable content trust, enable here, save it, and I'm going to Docker images. I'm going to say Docker tag. Let's see, I can just do this real quick because I had this up here. Scared. And pull this back. Thank you for bearing with me. All right, so now we're going to push it again. When I do this, it should ask me for, it didn't ask me for a digest here. Okay. Well, This fortune cookie didn't work out the way I really wanted it to, did it? Oh, that's why. You guys, you let me sit there and scramble for a minute and you knew what was wrong the entire time? Ah, jeez. Okay, now let's try this again. We're gonna just go back to 18 here. Oh, see, there it is. There it is. Okay, cool. We're back on board here. So, okay, now when we come back over here, what do we think is going to happen? All right, so we're signed, right? Everything's exactly the way it should be. Now, I'm going to go ahead and deploy this one more time. And now everything goes exactly according to plan. We can see that it's creating. Let's see. Scribe pod right here. We can see the image was pulled or was pulling already, so that's a step in the right direction. And if I wanted to, I can just pull it up and we'll do a little watch on it. Or not. Okay, there we go. So it's created and it started. Perfect. Exactly what we wanted, right? Now let's go ahead and I'm just going to look at my service real quick. So I'm going to say, I'm going to describe my service, which is Nginx, which is this load balancer that we had provisioned before. And we can see that the endpoint of 172.16.7.2.80 or port 80 is that Nginx image that we had already. I can actually go ahead and I can scale this, so I scale my deployment. So I'm going to say scale this deployment, or scale my deployment of Nginx, and I want, say, 3 replicas. So we should be able to say get our pods now, not POS. We can see that one's running, the other's creating right now because it's pushing to a different node. Let me go ahead and describe this service so we can just see real quick. So we can see that it's still applying the new IP addresses, what it's getting from that particular CIDR that we had seen with inside the UI of NSX. We can also see the load balancer, the ingress IP address, which has been assigned to it as well. And we can actually also see that with inside of our NSX environment over here. So I can go to load balancing with inside of the virtual servers. Once it gets up here and running, I can now see here is that default Nginx service that I'd created. If I wanted to get more information about it, I can. Let me go back over here real quick. So we can see that here's the particular IP address of where we should be able to hit it from the outside world. Outside world meaning in my environment here. And then, so there we go. Now we have our Nginx up and running. It's load balancing across all 3 of those replicas that we had done as well. Other cool thing that you can do with inside of here, with inside of NSX, is you can actually go and you can make sure that you have network traffic flowing between individual pods. You can actually port mirror and actually monitor some of the traffic that's going and verify traffic is happening between pods themselves. So that's the bulk of the demo right there. I'm going to go back over here because I've got 2 more slides to be able to just show, just sort of to wrap this up. So PKS is a fully supported Kubernetes distribution that does come from VMware. So it is a vanilla version of Kubernetes. We're not adding any APIs. We're not stripping anything out. So what you get with the open source version of Kubernetes is what you get with inside of PKS. What we're doing is automating a lot of those pieces for you by giving you those on-demand provisioning capabilities. And it's really built for day 2 operations, right? So you get everything, that complete stack from networking to security, confidence with inside of it. As well as the ability to tack on things, be able to take care of monitoring, logging information, and also patches and upgrades. If you want to do the same exact environment that I did, please go to VMware's Hands-On Labs. It's accessible online. That's the particular hands-on lab right there, 1832. And you'll get your own PKS environment with a bunch of information on how you can actually deploy your own cluster or your own applications. You can also look at what we're doing for persistent volumes. You can get a little bit more information on what we're doing with inside of NSX as well. Also, make sure you follow us, Cloud Native Apps, on Twitter. There's all of the open source projects that are coming from VMware on our VMware GitHub page. There's quite a bit on there. We're doing a lot of things with inside of Kubernetes and the container ecosystem themselves. We had talked about Harbor today. Harbor is one of those open source projects that are available there for you as well. With that, I'm available for any questions. I was asked that if you do have any to go to the mic though, so it can be recorded. So is it the fortune cookie that did it? There's no questions? Like, cool, we got one. Take it. That means you get a fortune cookie.
All right. So my understanding for the NSX side of things was that assumes that's already there, or is that part of the PKS cluster create that it actually stands that up? Because I saw you going to several different URLs for UIs to various VMware components, and didn't know if those were already assumed to be there or.
Right. So NSX is actually assumed to be there today. So it is actually part of PKS. So one of the prerequisites to actually, before you start deploying your Kubernetes clusters, we have to have NSX stood up and embedded into your environment. Once that's up and running, everything is tightly integrated with inside of PKS that it's actually, like I said, it has that CNI plugin to Kubernetes, and so you're essentially pulling all that information in, and you're getting all that native context from Kubernetes in itself.
Okay, thanks.
You got it. Fortune cookie. Look alive, I wasn't joking. If there's any other questions, again, thank you all for your time. Appreciate it. Have a great DockerCon. Hopefully see you tonight at the party.